Ignition sequence start. 6, 5, 4, 3, 2, 1, 0. All engine running. Liftoff. We have a liftoff.
The Spaceport Education Center is a satellite campus of the Florida Institute of Technology, specializing in graduate-level programs. Their Master of Science in Space Systems is taught by experienced professionals with real-world space industry backgrounds. The center is located next to Cape Canaveral, a real advantage for integration with industry. Its programs are relevant to current and future needs, including launch operations, mission design, and systems integration. Dr. Don Platt is the director of the Spaceport Education Center. He has a long-standing reputation in aerospace engineering and systems design and is known for blending academia and industry needs, not just ivory tower leadership. And he's also my guest on the Ex Terra Podcast. Dr. Platt, thank you for joining us.
Well, thank you. I'm really happy to be here today.
Let's start out kind of a little bit about you. What drew you to the space systems education, and how did your career path lead you into directing the Spaceport Education Center?
Sure. Yeah, I've always been interested in space and astronomy and anything really to do with science and engineering. In fact, my undergraduate degree was in physics and astronomy from Western Connecticut State University. And so I was looking at getting more involved in the space industry and trying to make a decision, did I want to do science or engineering? And then I happened across a degree program at the Florida Institute of Technology called the Master's Degree in Space Systems. And I said, that sounds pretty interesting. And I found out it was adjacent to the Kennedy Space Center. And I thought, well, what better place in the world to go to get involved in space than the Kennedy Space Center? And so I moved to Florida in 1995, received a degree in 1997, started teaching as an adjunct at Florida Tech in 1998. And so I've actually been involved with Florida Tech in the space systems degree ever since.
What was kind of your aha moment for getting interested in space? I know for me, when I was a kid, and I'm probably, given when you said you got your degree, I'm a little bit older than you, but when I was a kid in summer camp, and some of us that were older got to stay up late and watch Neil Armstrong land on the moon in 1969. That for me was kind of an aha moment to get me kind of very interested in what's going on in space. What was it for you?
Well, I think the first thing that I really remember was the Viking landers on Mars in the summer of 1976. I thought that was pretty fascinating. And actually, at the same time, my older brother had gotten me a telescope for my birthday. And so we went out on the summer nights in Connecticut and looked at the stars and tried to figure out what it was that we were looking at. So that was sort of a beginning phase. And, then certainly as the space shuttle program came along and the Voyager spacecraft flew by the outer planets, that all really got me going and got me interested for real in the space industry. And then I couldn't get enough of it. Every library book I could find, I'd read and read and reread and take notes and think about. And, I've really ever since then have been involved in highly interested in space.
I had a kind of a similar telescope experience. My cousin had one. We were out at his place down in Central Florida. And he said, let me show you the rings of Saturn. And okay, that's pretty cool. So yeah, I totally get it about the whole telescope experience.
Yeah, it's really amazing. And yes, you're absolutely right. The rings of Saturn were one of the first things. Jupiter and seeing the small moons of Jupiter that you could see with a telescope, and even training it on Venus and looking at Venus and seeing it and having it look like a tiny moon with a crescent. That was incredible when I first saw that.
Let's go back to the program a little bit, Don. And how does the program there differ from some of the other aerospace-focused graduate programs that you're aware of?
Yeah, our program is very multidisciplinary. So we look at all of the aspects that are needed to design, build, launch, and operate space vehicles. So we concentrate really on the real-world applications for space systems engineering rather than, say, the theoretical. So it really sets up the student to be an important contributor to the space industry and gives them a very varied background in all the critical elements needed to be successful in space.
Then who are those students? Are they industry veterans? Are they young professionals? Are they career switchers? Is it a combination? Who are you teaching?
Yeah, most of our students are young professionals, so they've had some experience in the industry. They're coming to us with a background in some form of engineering, typically. Some of them are in the military currently. Some are in commercial groups, and there's even some students that are working already at NASA. But one thing that we've had a lot of in the recent years was Air Force officers who were looking to transition to the Space Force. As the Space Force has really come online and grown over the last few years, there's been a number of Air Force personnel that have figured they could sort of get a leg up by taking our space systems degree. And I think for the most part, that has certainly worked out for them. And the students, and really, like I say, it's an extremely varied background. So we have some students that are aerospace engineering, some with a background in mechanical, electrical, software, some with more of a science degree, like space science, astronomy, or physics, like myself when I took the degree. And interestingly enough, we even have some military pilots and test pilots that have gotten into our program with the idea of getting our technical degree to help them in their astronaut application process.
What are the skills gaps that you're seeing that are most urgent in today's space workforce, and especially as we look at what we're now calling Space 2.0 companies?
Yeah, this is a very interesting time in the space industry and this Space 2.0. There's a lot of companies out there that are looking to get their products to market quickly, and this is true in the space industry as well. And an aspect of that also is have those products be as inexpensive as possible. And so I think we're moving a little bit away from sort of the more traditional thing where the very last percentage point of performance was needed in space. It used to be that they would have the smallest possible factor of safety on everything on the vehicle to sort of squeeze out the most mass to orbit, say, from a launch vehicle.
Sure.
Or make the lightest satellite that you could possibly make. We're seeing more of a design interest now in robustness, certainly reusability, and then, of course, the other factor is lowering cost. I always teach to my students that there are many trade-offs in space, and the student really has to be made aware of those, and that they're really a big part of what we do as we teach in our program. And space is still extremely hard. We've certainly seen that. There's been many high-profile failures. There's been a bunch of new launch companies that haven't been able to get to orbit. We've seen some of the commercial groups that have failed to land on the moon recently. So you really have a fine line that you have to walk to make sure that you are cutting costs, but you're doing it in the right way. So we have to understand where you can cut costs and where you really are going to be bit if you cut back too much. And I've always kind of prided myself on that aspect of the industry.
So you're running a graduate program there. Are students coming to you with the right background of skills in engineering and mathematics to be able to really keep up with transferring all of that to a space domain?
Yeah, well, each student is different. Mm-hmm. And so we make some we essentially tailor the program to every individual student in terms of what their background is, and so we try to get them up to speed. We have the very first course is called Intro to Space Systems, and so that provides 1 week of the term for all of the very critical disciplines in space, propulsion, communication systems, launch vehicles, the space environment, orbital mechanics, or what we call astrodynamics. And so that kind of gets the student up to speed in all of those important areas, so that make sure that they're competitive with their peers in every way. A mechanical engineer may really do well in the propulsion course, for instance, but
Right.
might struggle some in, say, the space power systems or communications course. So we try to make sure they have the basic backgrounds from that intro course to enable them to succeed in all of those various multidisciplinary backgrounds needed.
So let's talk then about how you tailor those curricula to keep up with the rapid pace of change in the commercial space sector, because as we all know, about the time that you get the news release about it, it's already obsolete.
Yes, indeed. And in fact, the low Earth orbit constellations was sort of designed with that in mind. They essentially are putting spacecraft up that they have an intent on only having operational for maybe at most 18 months to 2 years, and then it'll be
Hmm.
replaced with another one with the latest technology. That's a very different aspect of space now than it was in previous years, where it might take 5 or even 10 years to design, build, and launch a spacecraft up to geosynchronous Earth orbit, for instance, and then you'd have 10 or even 20 years to operate that spacecraft. So, it is very different. But as I said, though, the philosophy of today is not getting that last percentage point performance out of the system. Obviously, that last percentage point can be 90% of the cost. So we have to monitor the trends in the industry. And I think that's where we have an advantage. Our faculty, including myself, are working professionals in the industry who have years of experience in the hands-on world of building, flying, and operating space vehicles. And so it's very important that we maintain that monitoring and that interaction with the industry for us to be able to move forward in that way. And also, we need to listen to our stakeholders, groups like the Space Force and commercial companies, and even our students. Many of
Hmm.
our students are already working in the industry, and so they're on the front lines on a daily basis and feeding back to us the things that they're working on, the problems that they're facing. And I think that's a great aspect of our program too, where the students can interact with each other and learn from each other and what each one is doing, the challenges they're facing, the great things that they're working on. It's all really pretty amazing.
It occurs to me, and I wanted to ask how you feel like things have changed from the days when NASA was pretty much the big dog. Yes, there were always commercial contractors that worked with NASA. There were the Boeings and the Lockheeds and companies like that. But now with all these small companies, do you find that you have to kind of change the way you're teaching students in things like engineering and those kind and design because the companies are smaller that they'll probably go out and work for? They won't be directly working at NASA or at Lockheed or at Boeing.
Yeah, in fact, I had a mentor who liked to say that the 20th century was the age of the specialist, and the 21st century was going to be the age of the generalist.
Hmm.
And I think that is absolutely true. And I think that our program, with its multidisciplinary aspects, really does prepare students for the fact that they have to be multidisciplinary, especially in a small company. You're going to have a variety of different responsibilities. In every project, you might have a somewhat different role. No longer do you call in the specialist who all he does is write computer software to create, a calculation for thermal analysis of a very specific system on a spacecraft. Most of the people working in these smaller companies might have to design the entire thermal control system and be well aware of how it interacts then with every other component on the spacecraft, and how cooling of one component could have a ramification for an adjacent component. So yes, absolutely, it's a very different environment in a small company where you're doing many things and are interacting with a fewer number of people, but all of the people you're working with all have a varied background as well.
So then, do you feel like traditional engineering education models are keeping up to meet the needs of today's commercial space employers? And if you do, how would you like to see them changed?
Well, I think there are some things that do need to change. There is a critical element of the theoretical that is definitely needed for any engineering background. And certainly, if you're going to be an engineering educator or a researcher in the future, then the theoretical is extremely important as well. But I think for other industry professionals, people that are working on an engineering team and aren't necessarily wanting to go into teaching or research, then we really need to teach them the real world applications, real world examples, and hands-on exposure as soon as possible. And that's sort of a different paradigm than deriving a bunch of equations for a couple of hours on a whiteboard.
How many of your students, kind of as a percentage, do you feel like are of an entrepreneurial bent, that are looking to start a company rather than to go to work for a company?
I think we see more of that now, especially as some of these entrepreneurial space companies have become pretty successful. And so I would say that there's probably at least 30 to 40% of our students have some level of interest in entrepreneurship, or at least trying it. Sometimes entrepreneurship you can have a bug for entrepreneurship, but then when you actually go out there and do it, it's like, maybe it's better for me to go back to that cubicle.
That regular paycheck is a good thing.
I go somewhere where I know every 2 weeks I'm going to have a paycheck, and I don't have to mortgage my house for a second time in order to make sure the company is still going to be active.
And well, some of us were, as I say, involuntary entrepreneurs, but that's an entirely different program.
Right. But of course, again, with the small businesses and the small space companies, the Space 2.0 companies, there has to be some level of entrepreneurship involved with almost every employee. Every employee may have to, be concerned about making sure the next proposal is successful or the next test is successful, to make sure that they do, in fact, have a job and have a paycheck in the near future.
You mentioned the proximity to the Kennedy Space Center in Cape Canaveral. How important is that to your program?
I think it's very important. Many of our students are working professionals at the Space Center. And so, of course, then it's very important to have a site that is close by. Most of our courses are in the evening, and so they can come after work and take the face-to-face courses. If they need to stop by for some paperwork at lunchtime or something like that, then having a center nearby is very important. The main campus of Florida Tech is about 40 miles from Kennedy Space Center, so we're a direct outpost for the main campus at the center. And as students are out there working on rockets and payloads, then they have a place nearby where they can come to for classes and for any administrative things that they have to take care of as well. And then, of course, it also provides us the access to the working professionals who can teach courses for us as well. And, same is true then, that they can come right after work and pop into the classroom and teach the class more easily and readily.
So you're kind of the International Space Station of Florida Tech.
Yes, the remote outpost, right.
My guest is Dr. Don Platt, Director of the Spaceport Education Center at the Florida Institute of Technology. Take a moment right now to click subscribe to be sure you don't miss any of our podcasts, or if you're watching on YouTube, any of the videos from Ex Terra, the Journal of Space Commerce. And please consider becoming a paid subscriber. Whether you're a space professional or an enthusiast, paid subscribers have first access to premium articles and podcasts focused on the new space economy. Just visit xterrajsc.com on Substack and help keep the Journal of Space Commerce independent as we chronicle, cajole, and, when necessary, critique the commercial space industry. Don, are you seeing direct partnerships with companies like SpaceX and Blue Origin, who both have presences down in the Space Center, or ULA, some of those larger companies?
Sure, yeah. Many of our students come from those local industry groups. Should be noted that our degrees are offered virtually as well, so that we do have space professionals from around the country who are involved in those groups you mentioned, SpaceX, Blue Origin, ULA, who join our programs through a virtual connection. Should also say that we have recently signed an MOU with the Space Force at nearby Patrick Space Force Base. And Florida Tech will then be offering our MS in Space Systems, as well as our Space Systems Management, Contract Management, and MBA programs to Guardians at the Patrick Space Force Base site. Now, of course, Patrick Space Force Base is also the main training center for Guardians for the Space Force. And so I think it's great that the Space Force recognizes the importance of our degrees then for the future dominance of the U.S. in space, and making sure that the Guardians are prepared to ensure that.
Florida's Space Coast used to be kind of a sleepy place, and they'd have a launch once or twice a year, and things would go on, and there'd be a lot of people show up. But now the Space Coast has changed a great deal. There's been a great deal of growth, not only in just residential, but the number of companies, as we talked about SpaceX and Blue Origin, and a lot of smaller companies that are getting established down on the Space Coast. How has that changed the kinds of opportunities that your students and your program attracts?
Right. In the early days, at least early for me, what I like to say, around the turn of the century, or around 2000 or so, most people thought of Kennedy Space Center as, that's a place where they launch rockets. And there's not a lot of design work. There's not a lot of manufacturing that's taking place in the area. That has changed significantly. I think sort of a big inflection point was in 2011 when the space shuttle program retired. There were thousands and thousands of employees that were involved with the shuttle program, and the entire Space Coast recognized that they had to sort of reinvent themselves to become more competitive as we move forward in a very different domain that no one really knew what it was going to look like,
Mm.
honestly. We had no idea how long it would be before humans would launch from Florida again in the space, and it did wind up being about 9 years, in fact. But this was a time of great change and development, and there's a variety of different types of economic development agencies and programs throughout Brevard County that helped with that process. Even myself, I teamed up with the School of Business at Florida Tech, and we developed our MS in commercial enterprise and space at that time. Yeah, I guess I could say that it was a little bit looking forward or forward looking, with the amount of commercial development that has taken place in the space industry since then. And that program combined then some of our technical aspects of the space systems degree with business courses. And so, in the end, I think it was a great time to get that set up, and it offers then a broader commercial space industry uh, educational background for students. And we've certainly seen then groups like Blue Origin, who has built a tremendous number of facilities and capabilities on the Space Coast. And then, of course, clearly SpaceX,
Mhm.
OneWeb has been here for quite a while now. And a variety of other companies in Northrop Grumman down in Melbourne as well. And that really transformed the industry from relying on government space to more of this entrepreneurial space. And as the whole industry has changed, really the landscape of Brevard County and what we call the Space Coast has really changed as well because of that.
How much interaction do you have with Space Florida?
We've worked with them on a variety of different types of workforce development projects through the
Hmm.
years. They're definitely highly involved and interested in maintaining and improving and increasing the job outlook for the space industry here in Florida and here on the Florida Space Coast as well. So, we've been involved with them mainly from sort of a workforce development aspect.
Let's go back to the program just real quick and let's talk about how it addresses emerging areas like space traffic management. That's a big one these days, lunar economy infrastructure, and in-orbit servicing, which is starting to get really interesting.
Yeah, yeah. Our courses, of course, are always evolving as our instructors and even our students provide feedback to us. We're looking at making sure we keep up with the changes in the space industry. Space policy is going to continue to be important, whether that's from the space traffic management aspect or it's from national security considerations or it's from who owns the moon when people land there and start mining things or asteroids for that matter. One of the courses that we created as part of the commercial enterprise and space degree was a space policy course, and another one was a national security interests in space course. And so these are definitely courses that are continuing to evolve as those aspects of space evolve and change over time. And of course, people are sort of writing the book each day and reacting as new challenges in those types of areas come along. And so we're always having to make sure we tweak things and monitor them, make sure that we can respond just like we did at the end of the shuttle program to changes and updates in what's happening. As one example, we have an adjunct who is offering a hands-on course that's going into the details right now of lunar exploration and infrastructure. And so the students are sort of getting their hands dirty with lunar simulant and looking at how rovers and regolith and different aspects of the moon interact with vehicles and technology that's on the surface of the moon. And so we have a lot of those what we call special topics or independent study courses where we can introduce a new course as sort of the special topics and do so in a rapid fashion without having to go through the paperwork of a fully developed course that is going to appear in the course catalog. And so we can respond very quickly then to interests that students may have as well as new areas of space as they come forward.
Along those lines, are there plans to expand your curriculum into things like cyber and AI in space systems? And you mentioned commercial space policy.
Yeah, absolutely. We do have, as I said, the commercial enterprise and space degree that has some space policy aspects to it. Overall, as an institution, Florida Tech is definitely getting more heavily involved in cyber as well as AI. And we are always working with the main campus on ways to tailor those programs to space and to other areas as needed. The Space Force has definitely identified those as important areas, especially cyber and AI, for their guardians. And so as we move forward offering our curriculum at Patrick, we're definitely going to be integrating then the expertise that's developing rapidly on the main campus with our space expertise for cyber and AI.
What's your view, Don, on the viability and the long-term sustainability of the current space launch boom? It seems like every other day SpaceX is launching either from Florida or from California. And then we've got a lot of launch companies that are coming online. They're talking about rapid response. How sustainable is that pace?
Yeah, well, at the time of COVID, I was a little concerned about space investment, and I had really started to take off maybe a couple of years before COVID with a number of small launch vehicle providers, other companies like Astrobotic and Intuitive Machines and such who are doing lunar things. But it's amazing how well this new commercial space industry kind of was able to weather the concerns around COVID and the entire economic downturn then. But it is certainly important to have this competition in space, and that means then as many companies highly successful as possible, meeting the various needs. I don't think anybody, whether it's from national security perspective or from a commercial supply and demand perspective, wants to see only one company be successful. So it's very important that multiple space commercial groups are successful.
How? Go ahead. I'm sorry.
Sure, yeah. There's been several launch companies that have failed recently, and other companies, the lunar, concerns that we've seen recently. But we really do need to have groups working together, especially here on the Space Coast for launching. I think, already we've seen SpaceX do more than one launch in a day, but I think we're going to be to the time soon where multiple different companies are going to launch on the same day. And from that sustainability perspective, then also we have to have them not only work together for launches, but work together in orbit to make sure that these large constellations don't create any kind of a space debris concern.
How do we avoid paper credentials problems in this next wave of the commercial space workers?
Yeah, I think that the key is to make sure that the curriculum is always evolving, as I've mentioned, and meeting the needs of the organizations that are working in the space domain. So the students really need to understand then the multidisciplinary aspects of space and think about those trade-offs involved to be successful, and make sure that industry professionals with a real-world experience are involved in our program, not only from providing feedback, but and also certainly teaching our courses as well.
Just a couple of things more. First of all, let's talk about how people can get in touch with you. And I'm sitting here thinking that if there are people who are listening to this who might like to maybe audit a class or find a way that they can just find out more about it, is there a way for people who are interested in space to essentially audit a class and that they might find particularly interesting, or is everything going to be based on a tuition basis?
No, there is a level of audit capability that is out there. They can find out more information by simply going to fit.edu and then searching for space systems, and that'll pull up a connection to our space systems page, and from there to our catalog page, so they can look at the various courses that are out there, and they can contact me directly at dplatt@fit.edu. With any questions or ideas or comments that they may have.
And I will say that Don does answer his own emails, which I appreciate. Just one thing more, Don. What do you think space education should look like maybe in 2035, maybe in 10 years, and how do we build towards that now?
Yeah, sustainability is definitely a very important topic, and we can look at that topic from a variety of perspectives, honestly. The Apollo program was not sustainable. It was very expensive, and it was really uh, based upon a single goal, which was to get an American to the moon and return them safely to the Earth. But we need to teach sort of the entire paradigm of sustainability to go places in space for longer term reasons than the so-called flags and footprints. Honestly, I'm also concerned about the environmental impact of readily expanding space development. We need to understand those effects so that, obviously we're going to continue to ramp up the launches. We might get to a point where we have a launch a day, truly a launch a day with 350, 400 launches a year is definitely not unreasonable considering we're well over 100 already per year.
And they probably wouldn't even take Christmas off.
Very, very possibly. That might be a great opportunity to get on the schedule when it might be less less crowded.
Well, and orbital mechanics being what they are, that might be the only day they have available.
Yes, well, that's very true. Just look at the launch of the James Webb Space Telescope a few Christmases ago, honestly. But I think we need to make the students aware of all of those ideas of sustainability, environmental stewardship, and these future opportunities. There's great opportunity, but then also there can be peril if not done in the right way. So that's all going to be coming to the classroom in the next 10 years as we see it out there in the space domain.
Dr. Platt, thank you so much for joining me today. It's been a very fascinating conversation.
Oh, it's my pleasure. I'm glad that I was able to do this today.
Dr. Don Platt is the director of the Spaceport Education Center at the Florida Institute of Technology. And that's going to do it for this edition of the Ex Terra Podcast. You can subscribe to the audio version of the podcast on Spotify, Apple Podcasts, Audible, and many other popular podcasting platforms. Be sure to click subscribe so you don't miss any of our podcasts or any of our other videos. You can get daily updates on space commerce by subscribing to the Journal of Space Commerce on Substack at www.xterrajsc.com. And be sure to connect with us on LinkedIn and follow us on X at XTerraJSC. And please consider becoming a paid subscriber. Whether you're a space professional or an enthusiast, paid subscribers have first access to premium articles and podcasts focused on the new space economy. Just visit xterrajsc.com and help keep the Journal of Space Commerce independent as we chronicle, cajole, and, when necessary, critique the commercial space industry. I'm Tom Patton. Thanks for joining us.
I wanna go faster, faster. Hands in the air, we're gonna crash. Searching for the answers. My Galileo, the proof is looking glass. That's for reason. Our dreamer's eyes we gaze into a sense of purpose, known by view. Like finding water on the moon.